In this video, we're going to continue topic 6.1 and 6.2 on Riemann sums, and now we're going to look at the trapezoidal rule. So our goal is to ultimately try to get the best estimate we possibly can under the curve by drawing shapes under it. And we've done a pretty good job with rectangles. The midpoint sums seem to be pretty close. But if you guys remember, there's another shape we have called a trapezoid, and the one you're probably most familiar with is this, where we've got base 1 and base 2. But that's not going to help us out here because we've got a perpendicular kind of an angle there. So if I could draw a trapezoid like this, because the definition of the trapezoid is you just have to have a pair of parallel sides. We've got base 1 and base 2, or think about this. I could take that and I could put it on its side. And now I have something that looks like I could draw that shape underneath here. So let's think about what this looks like. So if I draw a point here and a point here, and I connected that angle. Do you see how I have trapezoid right there? And then let's draw another point. Point, a point, connect that angle, and now I've got another trapezoid. Okay. A point, connect it, and now I've got another trapezoid. And then we've got a point. Ooh, look at that steep one. And then another trapezoid. But do you notice how the trapezoids right here, they share that side? So we're going to have to take that into account to get the area of each trapezoid. And it's going to seem kind of weird because this is going to be your base 1, this is going to be your base 2, and this is going to be your height. But I'm going to probably talk about these guys being heights because they're the height of the curve. So it's kind of weird. So I kind of rename it as height 1, height 2, and distance in between is the way I'll say it. But remember, the formula for area of a trapezoid is base 1 plus base 2 times the height. And if it starts with a t, we divide it by 2. So triangles and trapezoids get divided by 2. So let's try one of these trapezoidal ones in this video. So I am going to start by drawing my trapezoid. That one's kind of a little tiny trapezoid. And then we've got this next one from here to here. And then I've got from here to here. And then I've got from here to here. And it said we had to go 5 this time. And then I've got from here to here. All right, I'm going to draw my table of values. We've done this table of values a number of times already. So we have x and f of x, and we're going to go all the way from 0 to 5. So 0, 1, we're going to use them all this time. 2, 3, 4, and 5. So when I put 0 into this x squared function, I get 0. When I put 1 in, I get 1. 2 in, I get 4. 3 in is 9. 4 in is 16. And 5 in is 25. I am now going to set up for 5 trapezoids. I'm just going to call it area. Sometimes people put area of the trapezoid down there. But the trapezoidal method, it's up to you. I'm going to set up a skeleton of a problem for 5 of these things. I know I've got to divide them all by 2. And then I know I've got a base 1 plus a base 2 times a height. So that's what I'm going to kind of set up for here. All right, so now I'm going to use the table versus the graph. So in this first rectangle, I know that my distance in between is 1. My first height is 0, and my first base, or my height of my function is 0, and the second one is 1. Okay. Now I'm going to go to the second trapezoid. So I'm looking at the purple trapezoid. I know the distance in between 1 and 2 is still 1. And then I know the first height is 1 and the second height is 4. Do you see how this 1 repeated? Okay. All right, then I'm going to go to the blue one. So in the blue one, I know my distance in between is still 1. And then I've got a height of 4 and a height of 9. So 4 and 9. And then I'm going to go to the purpley one. So the distance in between is still 1. And my height is 9 and my other height is 16. So 9 plus 16. And then finally the pink one, my distance in between is 1. My heights are 9, 16, and 25. And if you'll notice, look at how I underlined those even. The end ones will only get used once, whereas everything in between all gets repeated in there somewhere. So when I hit all the buttons, there is a shortcut. If, say, you had to crunch this out by hand, we could factor out all those 2's and do 1/2. And then I know it's all times 1, so I could just add up what's in the parentheses. So it'd be like 1 plus 0 plus 1 plus 4 plus 4 plus 9 plus 9 plus 16 plus 16 plus 25. I could do that. That's a way to shortcut this. Again, if you need to use your calculator, you may. And we get 42.5 on this one.